3 examples of complex conjugates. I want you to pause the video and think about it at least for 30 seconds, but no more than a minute, and try to look at the 3 examples. This is one number. This is its complex conjugate. So look at those 3 examples and determine if you can figure out what a complex conjugate is or not. Okay, if you haven't figured out, you should be able to complete this statement. And this is the general form. If there's a number in a plus bi form, its complex conjugate would be, and you should get a minus bi, because the only difference is the sign here. So in this case, negative a minus bi, its complex conjugate would be negative a plus bi. Notice there's no difference with the a and just the sign in between. Okay, so that's complex conjugates. Why do you need to know these? A complex conjugate is used in order to simplify complex numbers as fractions. When you multiply 2 complex conjugates, the answer is always an integer. Always an integer. So you don't have any imaginary numbers left. And just like with radicals, in order for a complex number to be in simplest form, you can't have an imaginary number, an I, in the denominator. So this denominator here, negative 4i, is actually in the form of 0 minus 4i, a being 0. So when we multiply the denominator, we should multiply it by positive 4i. So we'll multiply this by 4i and this up here by 4i. We do that and we get 16i divided by 16. You might say, well, why'd you do that? Because actually I could have simplified this before I started multiplying, which is okay if you forget that step. Clearly, I just did it. You'll just have to simplify it at the end. You might also say, oh, hold on. How did you get a positive 16 here? Well, because when I multiplied my 2 denominators, negative 4i times positive 4i was negative 16i squared. I squared is negative 1, so negative 16 times negative 1 was positive 16. So this will actually simplify to just I. Okay, why don't you pause the video and go ahead and try this one here, the 7 over 5i. Alright, so this, you could break it down to negative 7i over 5. And that would be your final answer there. Let's move on to here when we have more than just the imaginary component. When we're dividing by complex numbers, here we have 10 divided by 5 minus 2i. So we have an expression down here, a complex number. So in this case, like I said, we have to multiply it by its complex conjugate. So we're going to multiply it by 5 plus 2i. We're going to do that with both the numerator and the denominator. So this is why multiplying complex numbers came into play for us. All right, so multiply by 5 plus 2i. So doing that, distribute the 10 up here. 10 times 5 is 50. 10 times 2i is 20i. Here, FOIL, 5 times 5 is 25. 5 times positive 2i is 10i. Negative 2i times 5 is negative 10i. Positive 10i, negative 10i cancel. And then we have negative 2i times positive 2i. Well, that's negative 4i squared, which negative 4i squared goes to positive 4. Okay, so this is how I have 50 plus 20i divided by 25 plus 4. The 10i's cancel, or the 10i's cancel, and negative 4i squared goes to positive 4. So we'll combine our like terms here. So we have 50 plus 20i over 29, which that could be a way that your answer could be written, or it might be written like, could be written like this, because really you're doing 50 divided by 29 and 20 divided by 29. If either of these numbers have common factors, you can simplify it even further and break it down, but I don't believe they do. 29 is prime, so its only factors are 1 and 29. So that's as far as we can go, and that would be the final answer there. So if you feel like you have this down, pause the video and do the next one. If you don't, stick around and watch it, and I'll explain it again, or explain this one here. So the biggest thing is knowing, okay, it's a complex number expression here, division. I I have to undo that by multiplying by the conjugate. So we have to know complex conjugate. So if we have a number in the form of a plus bi, its complex conjugate is a minus bi. So we have to do that. So we're going to multiply both sides by 6 minus 6i. Both the denominator and the numerator are going to get multiplied by that. And then in this case, we are going to have to FOIL each. So 9 times 6 is 54. 9 times negative 6 is negative 54i. And then 3i times 6 is positive 18i. And then 3i times negative 6i will be negative 18i squared, which is positive 18. Then do the same for the denominator. 6 times 6 is 36. 6 times negative 6i will be negative 36i. 6i times 6 will be positive 36i, which cancel out. And then we have 6i times negative 6i, which would be negative 36i squared, which is going to go to a positive 36. So we have that, and then we can simplify by combining all of our like terms. So doing that, 54 plus 18, well 54 plus 20 is 74, so we have 72 minus, well 54 minus negative 36, so 72 minus 36i, and that's going to be over 72. So here you'll see an example of how we can simplify it down even further. Yeah, so the 72 minus 36i over 72 can get rewritten as 72 over 72 minus 36i over 72, and then we can simplify each term. 72 divided by 72 is 1. Minus 36i divided by 72 would be 1/2 I, or 1i over 2. Don't forget your checkpoint quiz, and then make sure you ask any questions you have tomorrow.